Hi everybody, my name is Justin and I'm going to talk about my heat pump today. So I've been through about 4 winters now since I got this heat pump. 2 of the winters I had some backup heat, and the last 2 winters I've used it exclusively for heating and cooling with a bit of resistance heat. Now I want to talk about the social, environmental, and economic aspects of getting a heat pump. I'll start with the environmental and start talking about why this is an important thing for Canadians to consider doing. As we all know, it's an important thing to lower our carbon emissions per household, and everybody should be doing what they can on that front, which is why I decided to go with this unit here. As you can see, I ordered it from Senville. They delivered it right to my house. It was actually quite an easy process to get a hold of it and research all I needed to about it. And the reason I made this choice is because this unit here actually delivers 5 times more heat than a resistance heater does for the same amount of energy. So it's basically like having 3 to 5 heaters in place of one for the same amount. Now, obviously it's using quite a bit of electricity, so there's some fairly heavy duty electrical cabling coming in here. There's a control panel here, and then what the actual heat pump does is it uses a trick of temperature between pressure and the refrigerant boiling temperature. It can actually take heat from even freezing temperatures outside and bring it inside. So we're going to go inside next, and I'll show you more things, more about the indoor units that go with the heat pump. So this is the indoor unit, and we are just on the other side of the wall. One important thing to realize about heat pumps is that you're slightly limited with where you can put the indoor units compared to the outside. There's a 16-foot hose reel that comes, and that's about as far as you get to go before you start to lose efficiency. Now, what's happening with this heat pump here is air is coming in through the top. There's just a simple mesh filter here, and then the heated air is coming at the bottom. In the summertime, this thing basically reverses and becomes a cooling unit inside. So we're taking some of the hot, we're leaving some of the hot outside and bringing some of that cool inside. Now, I'm going to pop the top here and show you what's going on inside. This air filter is removable so you can clean it when you need. The maintenance has been very easy on this unit. In fact, I've done barely anything to it other than about bi-weekly vacuuming of the filters. The unit comes with a remote control where you set the mode, the temperature, and just on-off status. And there's a bunch of programmable options and Bluetooth connectivity as well. I haven't used much of that because I'm pretty old school. So here we are with the downstairs unit. The outdoor unit can supply 2 indoor units worth of heating and cooling. So I use this one to keep my unfinished basement from freezing in the winter basically, but it also keeps it at a nice cozy 64 or 62, wherever you want to set it. I didn't want to fool around with attaching the indoor unit to the cement brick wall, so I installed a false wall there and just simply drilled in through the wood and brought the pipes in like that. Again, the electrical is coming from here. So it is a special breaker. It's a 40 amp breaker and some heavy duty wiring that will get that much power to the unit. One thing I will mention is that if I were to do this all over again, I would buy the casings that cover up the outdoor hoses. This foam insulation here is very important because it keeps the pipes, it keeps the cool or the hot in the pipe until it's reached the indoor unit. And outside, where it got a lot of sun, the insulation did degrade, so I had to replace it, which is why it looks like a cowboy did it. That's me, I'm the cowboy. This is continuing downstairs in my basement here. We're going to continue the environmental and economic aspects of a heat pump. A lot of people have asked, will a heat pump work in my house? And I think I've already shown that yes, you can get by with a heat pump as long as you're willing to use some resistance heating or some other backup heating when it does fall below -20. -15 Celsius is where the heat pump really does start to struggle. This is what came with my house. It's a furnace oil. This is a furnace oil tank. It's inside, and they would have to come every couple months in the winter, every month, and refill it. And then it was burned up in a furnace, and I have ductwork through the house. I decided to just go with a split heat pump for mine with those 2 indoor units because my house is so small that heat can reach the whole house. If you have a very large house, you may have to consider getting multiple outdoor and indoor units in order to cover all the different rooms. So for me, having a tiny house that is mostly open concept actually really was an advantage when I was getting a heat pump. I did the quick math on the cost of the furnace oil, and it was actually going to run me. The heat pump basically cost the same as 1 year's worth of heating oil, and I consider that a good investment. I'm 4 years in now, and the heat pump has paid for itself a couple times now, as far as I'm concerned. Okay, what I'm going to try to do here is tie the whole thing together. I'm going to talk about how heat pumps relate to sustainability and why I think it's an important thing for Canadians to wrap their heads around, and what is involved in making this transition into non-carbon emitting heating and cooling. As it stands right now, a lot of our heating and cooling, especially heating, comes from natural gas. And that's something that we'd like to displace from our grid. But when I look at energy, natural gas actually burns quite efficiently. So it's one of the last things I think we should be tackling as far as carbon emissions go. The reason I am an advocate for heat pumps, I do believe that they'll work quite well for a lot of people, but I hesitate to give a recommendation for everybody without any qualifiers. And the reason for that is I believe that a lot of people socially would be convinced to buy a heat pump, but what I do not want to see happen is people to buy a heat pump and then just turn around and say, I hate this darn thing. I got rid of my gas and now I'm freezing my butt off. So what I would say, is a heat pump right for you? Well, if you think it's crazy to have to wear a winter coat inside in the winter, maybe it's not for you. That's a huge point where I'm happy to put on another sweater. I'm happy to put on 2 pairs of pants. If it gets to minus 15, minus 20 outside, then that's probably what I'm going to be doing in my house right now with the heat pump alone. When it gets below minus 20, you do have to use some other kind of backup heat, and that can create some issues for some people, whether it be cost or whether it be comfort. Socially, comfort is the thing, and economically, cost is the thing. Now, the reason I showed my cowboy version of a heat pump is because I got that for a lot less than what a lot of people get quoted for when they ask a contractor, can I have a heat pump? A lot of these heat pump quotes, they come in around $12,000 or $15,000. And I find that to be probably more than a lot of people are willing to pay, even with the financial incentives. You end up, if I'd gone the financial incentive route to try to get some of the federal grants that go towards a heat pump or provincial grants, I would have had to spend a lot more money. So I'm convinced that the way I did it, I saved quite a bit of money. But again, a qualifier to that, I have friends that I could call in for favors and people that will come and do a half day's work for me. So one of the problems with a heat pump is that you end up needing an electrician and an HVAC expert. And between those two trades, you can end up spending quite a bit of money, especially if you ask them to do all the work. If you have them drill the holes, put the foundation down, then you're into more hours for skilled tradespeople. And that's not the best use of financial resources. Now, the other larger social issue when it comes to heat pumps is the power required to make them work. Now, right now in the summertime in Ontario, we use quite a bit of power because electricity is the main source of power that drives air conditioning. Now, if we flip that equation and use our air conditioners as heaters, well, we're going to see an equal or larger spike of power demand during colder seasons. Now, what that can turn into is an overtaxing of the grid. We are quite used to having a power spike in the summer for air conditioning, but that is mostly powered by natural gas generation. That is happy to take on that extra job, and the gas companies are, of course, happy to take the money. What I am slightly concerned about when it comes to the grid that we have, which is a very clean grid. Ontario's grid is wonderfully clean. So anybody thinking, if you lived in a grid where your electricity came from coal, that presents another complication in the carbon equation, but I would still say it's worth it. When it comes to Ontario's grid, the thing that I worry about is that if we all tried to heat with resistance heaters, that would overburden the grid, I do believe. If many millions of Canadians were trying to get their heat through electricity alone, that could create a grid problem. And if we convince enough people to switch over to a heat pump, and then it gets quite cold for several days in a row, you are going to see a huge spike in power demand. And I'm not sure that we as Canadians, as Ontarians, are ready to deal with that yet. We have quite a bit of natural gas, wind, and solar that can show up to do that job. But the renewables aren't always there, especially in winter. And natural gas can be needed across the board for a lot of different things. So that's one thing that socially we'll have to take a long, hard look at and prepare our grid to switch over to having millions of heat pumps in use. This could be slightly offset by a bunch of people using geothermal to power their heat pumps. Geothermal does get better consistency across the year because the temperature that the geothermal pump is seeing below the ground is just a nice steady temperature that works for heating and cooling. When it comes to the air source heat pumps, you do in fact hit a point where perhaps it's just too cold out there to get heat from the outdoors. I would say that I'm quite happy with my heat pump. It was a good choice. It saved me a lot of money and it's lowered my carbon emissions overall. I can't say that it would work for everyone all the time. If you have a big house that isn't insulated well, heat pump might not be for you. If you need to walk around in your boxers and t-shirts all winter, well, heat pump might not be for you either. But that doesn't mean that one of the best ideas I've heard to accelerate the adoption of heat pumps is to simply make all air conditioners heat pumps, because air conditioners are heat pumps already. All you need to do to turn an air conditioner into a heat pump is one tiny valve change that allows the process to work in reverse. So if you are interested in adopting a heat pump and you already have natural gas at your house, you can keep the natural gas, have a smaller heat pump installed, and enjoy the air conditioning in the summertime. And in the spring and fall, you can absolutely get most of the heat that you need to keep yourself comfortable from a heat pump, and then switch to natural gas when it gets cold outside. That is a perfectly viable way forward, and if you have the resources to do that, I would say go for it. How does all this tie into sustainability? How does this relate to sustainability? Well, it's pretty simple. One thing that I heard over the years of studying this subject that made a huge difference in my mentality was that climate change in and of itself is fairly abstract. It's hard to wrap your head around what you can actually do about that. An engineer I heard in a podcast once named Saul Griffith, he noted that it is time for the engineers to jump in on this conversation now, because what we're faced with, we know how to lower our carbon emissions. It is to electrify everything, as he would say. That means we need to put our heating into electricity. We need to move a lot of our transportation to electricity. We need to find a way to make concrete, natural, and ammonia and plastics without fossil fuel inputs. And that is a long-term project. That will take 50 to 100 years to actually solve that one. So let's start now. We can start now by moving what we can to electricity, and that involves cooking on your range, cooling with your air conditioner, and any other insulation and efficiency gains that you can get will help towards that goal for sure. Socially, we're going to have to convince people to do this because it's not free and it's not exactly a one-to-one trade. We need to have a social program where we convince people that this is the right thing to do and it's worth a tiny bit of sacrifice. I do believe that we won't get through this without any sacrifices, but socially, one thing we can't do is ask people to give up almost everything that makes them comfortable and happy. I truly believe now that abundance and prosperity are the ways to sell sustainability. One thing that we never talk about is air quality. When you burn natural gas, or in my case it was furnace oil, you're actually getting some chemicals in the air that you would rather not be there. You have to vent the exhaust to the exterior of the house, and we know that there can be problems with that. So socially, one way to sell these things is that life just gets better. One thing that I grew up with was smog days in Toronto, and that isn't a thing anymore. My kid doesn't have to worry about that. We don't hear about acid rain or smog days on the weather or the morning news anymore because we've largely solved that problem. We solved it by closing the coal burning plant at Nanticoke, and we mostly replaced that with natural gas, but mostly replaced it with nuclear. And that's why I've come around on the subject of nuclear as well. I do believe it forms one of the pillars of our decarbonized economy. Ultimately though, I'm gonna say that the heat pump was a great choice for me. I'm glad I did it. And I can recommend to anybody with the caveats that I've already told you about. I'm just gonna stop talking now. I've thought a lot about sustainability over the years, and the thing that finally made it a tangible problem I felt like I could help with was when it turned into an engineering problem. It's simply energy. That's what we're always coming back to, is energy. So if we have enough energy to power our heat pumps, power our electric ranges, power our air conditioners, we can actually survive in this climate, quite comfortable and happy, and not break the bank doing it. And I think if we can keep those three things in mind, environmental, social, and economic, then we'll be able to come up with solutions to climate change and sustainability that actually work for people.